Welcome everyone. We look at how do we solve limits by direct substitution. So we know limit as x approaches a of our function f of x will be f of a. Maybe we can take an example to illustrate this one. How do we get limit of x approaches 5 of 2x squared minus 3x plus 5? With this one, it is easier to get the limit of this one. Because we have limit as x approaches 5 of our function f of x is just the same as function of a. So in that case, it will be the same as f of a. Remember our a in this case is 5, so it will be 5 squared minus 3 times 5 plus 5. So we will get, this is 50 minus 15 plus 5. We will get what? We have this 25, 50. We will get what we call 40. So this is what we call the direct substitution. So we replace our limit as x approaches 5. So we replace with this 5. This is our 5. We replace wherever you have x with 5. So we'll have 5 squared, which will be 25 times 2, minus 15 plus 5. So we will be able to get 40. So maybe we can do another example on the same. That was example 1. We can do example 2. So we have limit as x approaches 1, where we have x squared minus 1 all over x minus 1. I know with this one, it might look a bit complicated because when you replace directly, you will get 1 squared, it is 1 minus 1 over 1 minus 1. So you get 0 over 0. Where this one, you know, in mathematics, it's a bit complicated where you get any number divided by 0, where you get an infinite number. So in this case, how do we solve this one? So this method, we cannot be able to solve that one directly, but how do we solve this one? I think by solving some linear algebra here, we can be able to show that this is limit as x approaches 1. With this one is where we have the square. So this is the same as x minus 1, x plus 1 all over x minus 1. What I have done this one, I have factorized this one, x squared minus 1, square of two numbers, so it will be x minus 1, the square root of this one and the square root of this one. This is x, this is 1. So x minus 1, x plus 1. So with this one now, you can be able to see that this one and that one will cancel out. So this will be limit as x approaches 1 of x plus 1. So in that case, when you replace now, you will get 2. Because you replace x with 1 plus 1, you'll be able to get 2. But when you replace directly the way it is, you find that you'll not be able to get the answer. So you need to do some operation when it comes to algebra, and you'll be able to get that x squared minus 1 is the same as x minus 1, x plus 1 when we open that one. So this one and this one will cancel out, so we have x plus 1 over 1. And now if we replace our x as it approaches 1, we replace with 1 direct substitution. Now we'll be able to get 2. Maybe we can do another example on direct substitution and see how we solve that one. So we can get example 3, where we have limit as h approaches 0. We may have 3 plus h squared minus 9 all over h. With this one now, we can be able to show that if we use what we call the direct substitution now, we will have our h is 0, so we have 3 plus 0 squared minus 9 all over 0. So you get it is 9 minus 9 over 0, which will be 0 over 0. Again, we'll be able to know that this will not be able to solve directly the way it is. So we need to do some what we call some algebra on the same. So I may solve this one and say this is limit as h approaches 0. I open this one. This will be 9 plus 6h plus h squared. When I open this one, because it will be this squared plus this one squared plus 2 times this one. So it will be 6h. 2 times 3 times h. So we have 6h. So minus 9 all over h. So with that one now, I may be able to simplify and get it as h approaches 0. 9 and 9 will cancel out. So we have 6h plus h squared all over h. So in this case, I can be able to solve independently. So you have limit as h approaches 0 of 6h all over h plus limit as h approaches 0 of h squared over h, where this one you get it is 6, plus limit as h approaches 0 of h, because h, one h and the other one will cancel out. So this one will be 6 plus 0. So we'll be able to get 6, because we said limit as it approaches constant, it is constant. Limit as h approaches 0 of h, now you replace h with 0, you get 0. So you get it is 6 plus 0, which we'll be able to get is 6. But if we solved this one directly the way it is, we could not be able to get the answer. So in that case, you can be able to see that we need to do some algebra so that we can be able to solve this one. Like the same case we have done with x squared minus 1 over x plus x minus 1. So in this case now, we can be able to solve another example. We see how. The other one, we factorize that one. This one, we have expanded this one. So we can see a situation where we need to multiply with a conjugate. And with those 4 examples, I think we can be able to proceed on how we can get limits for when we have now by trigonometry. So let's solve example 4. So we have limit as t approaches 0 of such an equation, where you have the square root of t squared plus 9 minus 3. So in this case, if we solve by direct substitution the way it is, you might find it is hard to solve that one, because you get it is square root of 0 plus 9 minus 3 over 0 squared. So in this case, you get square root of 9 is 3. 3 minus 3 will be 0 over 0. So again, with this one, we cannot be able to solve with that one, direct substitution the way it is. But we need to do some operations here, 1, 2, so that we can be able to replace directly. So how do we solve this one? In this case, we can be able to multiply with the conjugate of the numerator. So we have limit as t approaches 0. So we have square root of t squared minus 9 plus 9 minus 3 over t squared. We can multiply with the conjugate of numerator, which will be root of t squared plus 9. Now it will be plus 3 all over t squared plus 9 plus 3, because this is just like multiplying with 1. This over this one is 1. So when you open this one again, we have limit as t approaches 0. When you open this one, we will have square of this one minus square of this one. So we have t squared plus 9 minus 9 all over now this one t squared So as you can see, the square of this one, this is like what we said, if you have a minus b, this is the same as a squared minus b squared. So this is the same as that one. So we have this one times this one. So this is the same as this one squared, which is t squared plus 9. Because you square that one, the square root will cancel out. Minus now this one squared. Our b squared is 3, so it will be 9. So in that case, you'll find that it is t squared. So we have limit as t approaches 0, we have t squared all over t squared into bracket root t squared plus 9 plus 3. So in this case, you'll find that this t squared and this t squared will cancel out, because at the denominator you have the product. So you have limit as t approaches 0, we'll have 1 all over root t squared plus 9 plus 3. Now with this one, we can be able to replace t directly. So you have 1 over root 0 plus 9 plus 3. So I think with that one, you can be able to get it is 1 over 6. Because root of, when it is 0, we have 9. Square root of 9 is 3. Now 3 plus 3 will be equals to 6. So in that case, you can be able to, now we can be able to use now direct substitution to solve our limits. So you find that in some cases, you need to do some operation 1, 2, so that you can be able to apply the direct substitution. Not every direct substitution that will be able to solve this one, because you need sometimes to do some retro operation. So I can give an example 5. In this example 5, I won't solve this one for you, but at least you can see if you replace x with 1, you will get 8 minus 8, which will be 0. 8 minus 8, which will be 0. You will get 8 minus 8 over 8 minus 8, so it will be 0 over 0. So you cannot be able to solve with this one direct. How do we solve this one? You can go and try this one. Here we say we square both sides. That is numerator and denominator. And after squaring that one, you'll be able to solve this one. Now let's proceed to other method. How do we solve limits? That was direct substitution, where you have solved example 1 to example 4. And this one was example 5. But this one you'll be able to solve for yourself. Let's proceed to other limits now.